This recording is with regards to number 31 assignment C. Is based on hypothesis testing. This will be a chi-square test for randomness. It says the students patronize 4 snack booths according to the following distribution. Where is the distribution? Here it is. It's a table of values. Look at there. A, B, C, and D. There seems to be a factor affecting the manner in which they patronize the booth. So some students more might be going to one particular booth, less to another particular booth, etc. You are given the task of testing the following hypothesis by first completing the topic, research question, and objective. So the topic is students and snack booths. If you want, you can modify the topic. And the research question is, are the students patronizing the snack booths randomly? Or is there a factor influencing their patronage? How they go to the snack booth? Something must be affecting whether or not. So the hypothesis, not in mathematical format. For the chi-square test, it remains in worded form. So the hypothesis, the students are not patronizing the booths randomly. There seems to be a factor influencing their patronage. That is actually a claim by a fellow student. That's what the student is claiming. That's the hypothesis. So the objective is to determine whether or not the students patronize the booths randomly, or if there's a factor influencing their patronage. So to do that now, we have to do what we call a chi-square test for randomness. Here are the steps for the chi-square test now. So first, we have to identify the appropriate chi-square test, and then you have to state the pair of hypotheses. So to get the pair, to get what type of hypothesis, what type of chi-square, we can go on the top pages of assignment C, where we have the chi-square test for randomness, for variation, and for independence. So since the word randomness has been mentioned, so actually this is a chi-square test for randomness. And this will be the pair of hypotheses. The distribution is random. That's what the null will be saying. So you can just write the distribution is random, and the alternative will be saying that the distribution is not random. Or you can go to weekly notes number 9, page 7. That's where you have the 4 different types of tests: z-test for mean, and chi-square test for randomness. Here it is. And here is the null. The null will be saying the distribution is random. The alternative will be saying that the distribution is not random. So that will be the pair of hypotheses not to be translated to symbolic form. Okay? That's for the chi-square test. So here we have steps numbers 1 and 2 for the chi-square test. And it's a chi-square test for randomness, and here is the pair. And additionally, even in the assignment itself, in the steps, here you have the 3 chi-squares and the pair of statements, and we are doing a chi-square test for randomness. Number 3, step 3, to sketch a distribution curve for the chi-square. It will be skewed towards the right, unlike the z-test, which will be a normal curve. And step number 4, the critical region will always be on the right for the chi-square test, and the critical point will be on the right for the chi-square test. So we can simply take a snapshot of this diagram there. Step number 5 says to place the critical value on the critical point. The critical value will be provided. The critical value here is 11.345. Here it is. So here is the critical value on the critical point. So now we move on to step number, well, actually that is 3, 4, and 5. We're moving on to step number 6. Calculate the test statistic now. So once we have the critical value located, now we're going to find the test statistic to compare on the curve. Here is the formula to calculate the test statistic for a chi-square. Oh, by the way, the chi is a Greek symbol, the Greek symbol for the song chu. In English, we use ch for chu, but in Greek, this is the symbol they use for the song chu. Chu for what? Chu for change, I suppose. It's a test for change. Now here I went to weekly notes number 9, page 17. That's a chi-square test for randomness. Here is the formula. O minus E all squared over E, sigma thereof. The observed values will be the values in the table. These are the observed values. That is what the researcher observed. 93 students went to A, 70 to B, etc. The expected values must be calculated using this formula. We have to find the average of the observed for the chi-square test for randomness. So bear that in mind. So we have transferred these values to Google Sheets, 93, 72, 42, and 45. These are the values that we observed. The average now will be the expected. That's for the chi-square test for randomness. So we find the average of the observed. That's the average of A2 to A5. So the average is 70.5. That will be the expected value. So the expected value is 70.5 all the way. So now we are in a position to apply the formula O minus E all squared divided by E. Here it is. O minus E all squared divided by E. And then we have to add this up, and this will give us our chi-square test statistic. So let's do the O minus E all squared divided by E. In this column, open bracket, O minus E all squared divided by E. Let's do that there. Equal, open bracket, O minus E, close bracket, all squared divided by E. So that's our first chi-square, control, enter. And here, these are our chi-square contributions, 4 of them. And when we add this up from C2 to C5, this sum there will give us our chi-square test statistic. We got it to be 19.02. We can reduce the number of decimal places, 2 decimal places, 19.02. That's how we can calculate our chi-square test statistic. Step number 7 says to plot the test statistic on the distribution curve. You must look at the value of the critical value in order to plot the test statistic in the correct position, because the critical value is already there on the curve. So when we go to our curve, 11.345 is already there, the critical point. Now we need to plot 19.02. Oh, by the way, 0 is right at the beginning for this curve. 0 is in the middle for the normal curve, that's for the z-test, but for the chi-square, 0 is at the beginning, because the chi-square is always right. Now we need to plot 19. Clearly, 19 is more than 11. $19.02. Let's create a point to demark where our test statistic has landed. anywhere on the right side of 11. So we move on to step number 8. That's step number 7. Decision time. Reject the null. Again, reject the null if the test statistic is in the critical region. Do not reject the null if it is not. Where is our test statistic? Our test statistic, here it is. It's in the critical region. So we've got to reject the null hypothesis. And that's what you simply write. Reject the null hypothesis. And we go to step number 9, which says conclusion time. If the null is rejected, the alternative is the conclusion. If the null is not rejected, the null will be the conclusion. Always remember that you will start the test with 2 statements, the null and the alternative. After the test is done, only one will be the conclusion. In this case, since we reject the null, then the alternative is our conclusion. And what is the alternative saying? That the distribution is not random. That's what the alternative is saying. So this will be our conclusion because we have rejected what the null said. So we always begin by saying based on the data, and we are going to quote the alternative, which is saying that the distribution of the students' patronage towards the booths, I'm just adding a little salt to it, is not a random factor. It's not a random activity. There seems to be a factor of influencing, right? Their patronage, which of course, that was hypothesized already. That was the claim. So the data has actually proven the claim. So that's how you perform a chi-square test for randomness.